Hi there, welcome back to the DevOL. I am Roman and this is the 5th episode of our Event Sourcing Do-It-Yourself video series. The last episode finished with a bug. We copy and pasted some lines of code, just glanced over a bit and introduced, I think, a pretty severe bug in our nice and small application. And I think that this is quite common in normal software development. You copy and paste something here, you think something is working, and in the end, it's not. So the solution for this would be to have actual tests in our business logic. So, los geht's. Alright, so we have implemented our new behavior. So for now we have events, projection and event store, and we have the actual business logic. But in the end something went wrong. And the reason for this was that we didn't have any tests. So how can we actually implement those tests, and what kind of tests would be nice when we are doing event sourcing? I'd recommend that we are using BDD style tests. With BDD style tests, I don't mean that we're doing actually BDD now, behavior-driven development. We're just taking a small part out of it, which is the test structure that we can use especially well in combination with event sourcing. What do we mean with this? How do the BDD style tests look like? In these kinds of tests, we always work with given, when, and then. So we have a precondition, which is the given. Then we have an action, which is the when. And we have a then, which is the expected outcome. And the nice thing is with event sourcing is that we don't have a state, and we do not need to really build a state within our application. The only thing we actually need to give to our tests is a set of events. And then the when is the action that we are going to do, for example, sell flavor. And the outcome is another set of events. And that's it. We do not need to build up any state. We do not need to mock anything. We just have a list of events. We have a function for the action, especially nice in a functional language. And then we have the expected outcome. So for example, we say that we have a list of 2 events as our precondition. So we say that the flavor was restocked for vanilla and it was restocked with 2 portions. And we have already sold 1 vanilla. When we do something, when we actually sell flavor vanilla, we expect a specific outcome, which is in fact a list of 2 new events. The first one is that the flavor was sold and that the flavor vanilla went out of stock. And this is what we actually need to do in our program to test our behavior. So let's just implement this in F# with the goal to actually just in the end copy and paste these slides into our code. And I promise you that this is possible, and in the end we have really nice tests that you can show to your business owner or to anyone who has a clue about the domain. So let's implement our first test. In order to be able to run our tests, we need some kind of a test runner or kind of a framework. And for this, I chose the, in my opinion, pretty awesome Expecto library. Expecto is an F# testing library and is also a test runner. And it has the, in my opinion, pretty unique notion of all your tests are actual values or functions that you can run during program runtime. Which means, for example, for us now, we can just grab a list of tests we define and run them in our sample application, which is pretty nice. I installed Expecto via the packet manager packet or packet, but I'm not going to show you how you're actually installing it now. I put a link in the show notes down there, but it's the normal way to install new packages into your F# or C# or .NET programs. So I prepared some boilerplate so that we can actually start implementing our test. I just walk you through the boilerplate that it's not too much magic for you. So what we want to call is we want to call a function called runTest. And this function is defined in our helpers in here, and it uses the runTest function from Expecto. It uses a default config, and it takes all the tests that are defined in the test module in the test identifier in here in the test value. So how did we define this? I already opened this. This is the test module where we are going to write our tests in. We open the Expecto library and also the expect module of the library. And then we just define the value tests here. And tests consists of a test list. And in here we can put as many tests in there as we'd like to. And then this is a neat syntax, I think. So we just say this is a test and give it a name, and in our case 1 equals 1. And then we have this curly braces syntax here because internally it uses a computation expressions for doing all the tests. And then we just say equal 1 and 1 and a description of what should actually happen. So 1 should equal 1. And then we can just run this. And because of this line down here, the tests are run before all the other stuff is happening. So as we can see here, the tests are running and it says one test is run in 0.0 blah 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 seconds and the test passed. And if we want to have another test, for example, we could just copy this here and say now we want to prove that 1 equals 2, and we have here 1, 2, and 1 should equal 2. And then we can rerun our program and therefore also the test. And we see that we get an error now. So the example 1 equals 2 failed. 1 should equal 2. Actual value was 1, but had expected it to be 2. So that's pretty nice and pretty neat, and we can just write our tests within our program and even run them when our whole application runs. So now that we have done this, we can start actually implementing our own tests for our own behavior. So we can make this a bit smaller here, and we can clear this up, and then we can get rid of this example test and write our first new test. So for example, we want to test the self-flavor behavior in our system. We want the flavor sold happy path, which means we have a couple of current events in our system, and these are all the events that should have happened in our system before we actually call self-flavor. So for example, flavor restocked, vanilla 3. This is the one event that happened in our system. And then we could actually call the behavior of our system. We could say let new event equals behavior self-flavor vanilla, and as the events, because the self-flavor function, if you remember, takes as the last parameter the events, we give it the event that we have just defined. So now we have the events that happened before, and we say when something happens, and we get something back. And now I want to define another list, which are the expected events, and this is the list that we expect to happen in our system, and this in this case is one event which is flavor sold vanilla. And now we can call expecto and say we expect the new events to equal the expected events, and this is not expected, this is equal. And we say the new events should equal the expected events. So we have just written our first test. And when we run this test, we see that we immediately get an error. Why is this? Well, let's see. The new events should equal the expected events. The actual value was flavor was not in stock vanilla, but we had expected it to be the flavor sold vanilla. So this is actually exactly what was happening in the last episode. So we were saying here that we were restocking the vanilla, and then we were trying to sell the vanilla, but we got flavor was not in stock, but we expected it to be flavor sold vanilla. So let's fix this now, and then we can make the test a bit nicer actually and implement more tests. So let's have a look at our projections. This is the function that we have written to actually restock our stock of our flavors. If you think back to the last episode, we created a new projection called flavors in stock. And in there, we copy and pasted a couple of lines of code to create a new function called restock. And this function actually tries to find a value in the map, and if it's there, we are going to update the value, and if not, we are going to return the old map. But if you have a closer look, this is wrong. Because what are we going to do here? We say, okay, let's take the map, try to find the flavor, and only if we find it, we are actually updating the map of the stock. And if we're not finding it, we return the same stock that we started with. But this is actually quite problematic, right? Because in the end, the stock is always empty. So have a look at the inner part of the projection. We say that we have a map empty. If we want to update a flavor in the stock now, we never will find any. So we never updating. So we always return the default value, which is the stock that we have given the function. So in general, our map will always be empty. So it's an easy fix, I think. So we can just say, if we don't find flavor, then the default value is 0. And then we don't need the option value here and default value anymore. And we don't need the option map anymore because we always have a value. So we can just use the normal lambda function here. And then we always update the map, so the current state of the stock, with the new value. So if it was not in there, we updated it with a 0 plus the number that we are going to restock this. So if we are going to rerun the test now, we see that the test is working now. We have a sale flavor 1, it passes, and everything is as we have expected it. Because now we see here, after we restocked the vanilla with 3, let's go down there to see the code again. We say sell flavor, which was not in stock, results in those events. And then we get the restock action, and it was restocked. And in the end, we say sell flavor vanilla, and now we get a flavor sold vanilla event out of it. And the stock of vanilla is still 2 because we restocked it with 3. So everything worked out as expected. So it wasn't a big fix, but it would have been nice if we catched it in the beginning and not maybe in production or somewhere too late. All right, let's now make the test actually look a bit nicer. And in the beginning, I promised you that we can actually copy the tests from the slides I have given you. And this is what we want to achieve now, or what I want to achieve now. I want to build with you a domain-specific language, a DSL, for the test so that we can use a given when then syntax in our test. And we can actually talk to the business with those tests. We can talk with the business owner, with the product owner, and talk to them or discuss with them if this is the expected behavior. So let's go back to the tests and let's have a look at those tests here, because this is not really easy to read, I think. So let's write our own domain-specific behavior. So we want to have this structure: given events, when action, then events. So this is what we want to achieve down here. Let's write this down, and let's write the API first, and later on let's fix the code to actually make it work. What kind of test do we want to have? We want to have given a list of events when behavior sell flavor vanilla, then we expect flavor sold vanilla. So this is the syntax that we want to achieve. Given some preconditional events, when something happens, then I expect these events to be emitted. So let's write this. We want to use this pipeline style syntax here, which means for the given, we give it some parameters, which are the events, and we just want to return the events, because this is just for readability. We just say given events, we return the events. So we can use the output of this function here in the pipe in the input for the when function. And if sharp is nice, it has a nice function that actually is doing this, which is the ID function, the identity function. So we can actually just use given as an alias for the ID function. So the ID function takes an input and returns it as the output. Now we want to define the when function. So how should it look like? The when function takes something and it takes the events from the output of the given function, which might look a bit familiar for you now because it's similar to the eventStore.evolve function. So what is this here, if you remember? Right, this is an event producer. So we use the event producer, and the second parameter is similar to the evolve. It's the events. So we say now event producer and call it with the events. So this is our when function. And now we need to implement the then function. So the then function gets the output of this as the second parameter of this when call, and the expected events as the first parameter. So we have the expected events and the actual events as the second parameter. And then we can pretty much copy and paste this and say here the actual events should equal the expected events. And that's it. Now we have defined a pretty nice domain-specific language that you can actually read. It was not too much of code. It was like 6 lines of code to actually implement this. We can even shrink this further if we want to, but it's not too much code. And now we have a really nice DSL for actually working with our tests. So let's make this here even a bit smaller. And as you can see, now we can really read those tests. Given these and those events, when something is happening, then the expected outcome should be like this. So let's run this again to see if it still works. And as you can see, my tests are still running. Cool. Now that we have defined this nice syntax, it's pretty easy to write new tests. So for example, let's write 2 more tests. Flavor sold, flavor went out of stock. How should this test look like? I think we can already copy this again. And we could just say, okay, now we have something like this. We say given. We have the flavor restocked vanilla, and we have a flavor sold vanilla, and we have another flavor sold vanilla. When we sell 1 more vanilla, we expect a flavor sold vanilla, but we also expect our events to look like this. Flavor sold and flavor went out of stock vanilla. And then we can define 1 more test, which says flavor was not in stock. Oh, let's actually copy this again because it's pretty easy then. We can again say this one, but now we even have sold 1 more vanilla, and when we're going to try to sell another vanilla, we don't get those events here. What we are getting is flavor was not in stock vanilla. So, and hopefully these events should run now, or these tests should run now just fine. And as you can see here, all our tests are working just fine, and we have just written our 3 first tests for our nice little application. So I hope that I have convinced you that for a nice event source system, you not only need events and an event store and projections and your business logic, but you also need testing. And I think this is pretty much true for pretty much every program we are writing. But the nice thing with event source system is that testing is so easy and simple. You don't need to set up so much stuff. You don't need to mock a lot of stuff. You don't need to build your whole application state of your database in your test. You just give a couple of events in, you have an action, and you expect a couple of events out. That's it. And then if you have a nice language like F# and testing libraries like Expecto, you can write yourself a really easy and simple to read domain-specific language for your tests that allows you to actually talk about your tests and discuss your tests with your product owner, your business owner, or whatever stakeholder you can get hold of. That's pretty cool, I think. So that almost concludes our series, but you might have asked yourself one big question during the whole video series, which is, where are my aggregates? So imagine we are not talking about only one ice cream truck anymore, but we're talking about different ice cream trucks. Or we are going to expand our whole company and have different stuff to manage. Where are we going to put those events and how are we going to work with them? Because we don't know for which ice cream truck I have just sold my flavors or I have just restocked. This is just not in our system at the moment. And this is what I'm going to use to conclude the series in the last episode. I really hope to see you there, that you stay with me for the whole 6 videos. So next video episode is aggregates and event streams. See you there. Bye bye.